Hi, I'm Luke. I'm actually one of the original members of Team Ursa from back in 2011 when we were just a group of students at the University of Maine. And I'm here to try to explain briefly, if I can, what our group is, what we do, and why we're currently embarking on this fundraising effort. So our group is primarily STEM education oriented, and our goal is to use suborbital space exploration as a tool to foster students' interest in STEM. So that's our big picture goal. Get students excited about STEM, try to get them into STEM careers. We just feel like it's an important field in the world. We're all engineers, we love it, can see the importance of it, and we just want to try to pass along the excitement. So that's big picture. So as a group of primarily engineers, we've decided to go about this goal by creating a reference design repository of launch vehicle designs and of payload packaging designs. So currently, if you're a student or a scientist or a professional and you have an experiment that you want to send into space, your options are fairly limited. You can either get a fairly expensive launch on a NASA or commercial sounding rocket. There aren't that many of them out there, but you can do that. You can try to get a ride on a larger launch vehicle that's launching a satellite. That's fairly competitive, and if you're a school and you do that, that means that your payload is actually going to be in orbit, which is very cool, but that's often out of the reach of schools. Beyond their resources, so it's not really necessary. Students will get excited just from a vehicle that goes into suborbital space. They get to fly their experiment on that vehicle, expose it to space for a couple of minutes, do their experiment and get it back. The last option is actually using balloons, which are cool and they're very simple and easy, but you're not going to actually get all the way to space using those. So we don't want to claim that we're going to be a cheaper solution to get into suborbital space, but that may happen, may be the case, but instead we want to create this repository of open source reference designs for launch vehicles and for the payload packaging system. So what can happen is students, professors, professionals, whoever needs them, can take these designs, build them, test them, fly them, use them to run their experiment. They will often make corrections and improvements. They can resubmit these designs, and over time they improve, just like any open source model works. And our friends at Maverick Civilian Space Foundation, who have been our mentors over the past couple of years, have the infrastructure to build such a repository. So that's what we're fundraising for, is to create these first designs, to do the research and development, to create the designs so that we can put them in the repository. So we're planning on doing all of it, the launch vehicle and the payload packaging, but primarily the payload packaging units, as we call them, are our first goal, and that's our first fundraising goal, is to create the first payload packaging unit and test it, test how it separates from the other payload packaging units. Every school or every person who's flying something on a vehicle will have a separate payload package unit. They'll be snapped together into one vehicle. We want to test one of these units and the separation between them. So that is our first goal. But eventually we will be working into developing the reference designs for the entire vehicle that launches these. And that may sound ambitious, and it is, but we have some experience doing this. The Ursa 1.0 was a fairly large launch vehicle, and we built and designed that as college students. We flew that last fall, so we know it's involved. We certainly know how hard it is, and we know what the technical challenges are, but we need to sort of work into this, and our first step are these payload packaging units. After that, we will be working up into larger and larger vehicles, and eventually the Ursa 2.4, as we plan to call it, will be the first one to send these payload packaging units to space. So if you'd like to support us, please share our project on Facebook or Twitter. We appreciate that very much. Or perhaps make a donation to our crowdsourcing effort, which we have hosted on the Maverick Civilian Space Foundation website on a service they're calling the MavNet, which is sort of like a Kickstarter for space-related STEM projects. So thank you very much for listening, and thank you for your support.